Hello dear students, we are having lecture number 2, that is part 2 of grouping of cells. When we consider cells, I think we had 2 other lectures also. Okay, this is grouping of cells. Grouping of cells already we have covered series combination. We have just started parallel combination also. Today we will continue with the parallel combination, then we will do mixed grouping also. So regarding series combination, we had arrangements of cells like this. Okay, just like this, then n times. Okay, then we can have external circuitry also. So external resistance can be like this. So what was I? So here equivalent EMF was E1 plus E2 plus just up to En, and R equivalent was R1 plus R2 plus up to Rn. Okay, then if the current that is passing through this resistance, if this is R, then E equivalent divided by R equivalent divided by R. This was the current. Suppose if this is E1 R1, okay, E1 R1 R2 E2 R3 E3, then we will have R and En also. Suppose if we have same electromotive forces, okay, same resistance, likewise if we have, okay, up to En. So this is E, this is also E, R. If we connect an external resistance also. So in this case, E equivalent was what? E plus how many times? Up to N E's. So we will have Ne. This is what E equivalent. What about R equivalent? R equivalent will be Nr. So in this kind of situations, okay, what is the current? Current I is equal to Ne divided by Nr plus R. This is how the current, okay, through the resistance. Clear? This is what is series combination, which we have seen. We have done some problems also. Then parallel combination also we have derived. Okay, so for parallel combination, okay, we will have one cell, another cell, okay, just like this, and we may have an external resistance also. So let this be E1 E2 R1 R2, external resistance R. So this one we have derived E equivalent. So in parallel combination we won't be able to separate this battery and resistances. So E equivalent is nothing but E1 by R1 plus E2 by R2 divided by 1 by R1 plus 1 by R2. So for 2 cells, this was the combination. So if so many cells are there, E equivalent is nothing but E1 by R1 plus E2 by R2 up to what? En by Rn divided by 1 by R1 plus 1 by R2 plus up to 1 by Rn. Okay, this is how it is. If so many cells are there. Now suppose From here we will continue from the last class. Suppose instead of this kind of polarity, negative will be connected to this junction, negative of this battery also connected to this junction, we can say they are in same polarity. Suppose the positive is connected to this junction, negative of this is connected to this junction, what will happen? E equivalent will become E1 by R1 minus E2 by R2 divided by 1 by R1 plus 1 by R2. Okay, whichever cells are arranged in the different polarities, that we will have to subtract. Okay, no changes will happen to resistances. Okay, now what will be R equivalent? R equivalent just a parallel combination, right? They are parallel combination. 1 by R equivalent is nothing but 1 by R1 plus 1 by R2 plus up to 1 by Rn. This is how the parallel resistances will appear. Clear? So suppose if we need to find the current, this is nothing but E equivalent we need to find, divide by R equivalent plus R. Okay, this we will have to find and substitute. Clear? Suppose if we connect cell E, internal resistance R, again cell E, internal resistance R, likewise so many, and finally we connected like this. So this is E, again R, one row, second row, nth row, finally we have connected an external resistor also. So what will happen? Suppose if we try to find E equivalent, so this is nothing but E by R plus E by R plus, likewise we will have nth E divided by R, divide by 1 by R plus 1 by R plus dot 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 1 by R. Clear? This is how it is going to come. Suppose if we take 1 by R outside in the numerator, then we will have E plus up to N E's we will have. Okay, N E's. And here how much we can have? If we take 1 by R outside, this is going to be 1 plus how many times? We will have 1 up to N times. Okay, so 1 by R will get cancelled off. What will be this? This is going to be NE divide by, if we add this 1 plus how many times? N times. This is going to be N. So this N and N will be cancelled off, and E equivalent is going to be just E. Correct? No? Just E. Same way, if we try to find 1 by R equivalent, this is nothing but 1 by R plus up to 1 by R nth 1 by R. Correct? So if we take R outside, 1 by R equivalent, if we take 1 by R outside, this is going to be N. So R equivalent is going to be how much? R by N. Okay, now these circuits are parallel wires. All these are parallel wires, and the value of EMF, they are also same, and these resistances are also same. So definitely the voltage across these terminals, this one, all will be same. Every voltage across these points will be same because they are all parallel. So definitely here also what we will be getting? We will be getting only E. Okay, so that is why E equivalent is equal to E itself in parallel circuits. Take down. So do this question. they are asking the potential difference between the terminals A and B. What is the potential difference between A and B? So no current will be passing in this circuit. This is not connected to any external circuit. Okay, no external resistance. So we can say the terminal potential difference is what they are asking us to find between A and B. So that is nothing but EMF itself. So potential difference between A and B is nothing but equivalent EMF. If current is flowing through the circuit, then we will have to find the terminal voltage. That will be different. If current is not flowing through the circuit, then the terminal potential difference is EMF itself. We have studied this. So in this circuit, current will not be going through the outside circuit. So potential difference is nothing but E equivalent itself. So what is E equivalent? E1 by R1 plus E2 by R2 plus E3 by R3 divided by 1 by R1 plus 1 by R2 plus 1 by R3. So if we take E1 by R1, 1 by 1 plus 2 by 1 plus 3 by 1 divided by 1 by 1 plus 1 by 1 plus 1 by 1. Correct? No? 1 by R1 plus 1 by R2 plus 1 by R3. So this is going to be 1 plus 2 plus 3 divided by 3. So 6 by 3 we are getting 2 volt. So that is the answer. Clear? Okay, I will summarize this. Since there is no current is passing, okay, there is no external resistance. If external resistance is there, current will be passing. Otherwise current won't be passing. So here no external resistance. So the EMF itself is the terminal potential difference. When they ask the potential difference between the terminals of the cell, okay, whether this terminal or this terminal, both are fine since no current is passing. Okay, so potential difference across the cell is nothing but the potential difference across the external resistance. Potential difference across the cell, okay, both are same. Since no current is passing, the potential difference will be equal to EMF. So this is the formula for finding the equivalent EMF when the circuit is parallel. So this is a 2019 JEE mains question. So students, this is another question. Again another JEE question 2011. Two batteries of different EMFs, okay, and different internal resistances are connected as shown. The voltage across AB. So voltage across AB, no external resistance, no current will be passing through the external resistance, no circuit. So EMF and terminal voltage both are same. EMF is equal to terminal voltage when no current is flowing, and terminal voltage is nothing but the voltage across the cell or voltage across the external resistance if external resistance is there. Okay, so again what is this? Okay, what we need, voltage across AB is nothing but E equivalent. So E equivalent is what? E1 by R1 plus E2 by R2 divided by 1 by R1 plus 1 by R2. So what is E1? 6 by 1 plus 3 by 2 divided by 1 by R1 is 1 by 1 plus 1 by 2. So this is going to be 6, this is 1.5 divided by, this is 1, this is 0.5, this is going to be 1.5. So 7.5 divided by 1.5. In 3 there are 2 1.5s, in 6 there are 4 1.5. So 7.5 we will have how many? We will have 5. So answer is 5. And take another question. 3 cells of EMF 3 volt, 4 volt and 6 volt are connected in parallel. if their internal resistances are 1 ohm, 2 ohm and 1 ohm, find E effective, that is equivalent EMF, then find R effective and current in the external load. Okay, current in the external load 1.6 ohm. Okay, so we know E effective is nothing but E1 by R1 plus E2 by R2 plus E3 by R3 divided by 1 by R1 plus 1 by R2 plus 1 by R3. So E effective is equal to E1 we can consider as 3, R1 is nothing but 1, then E2. So E2, here the polarity is changed, this is minus plus, this is plus minus, so we will have to consider that. So minus 4 divided by 2 plus 6 divided by 1, there 3 volt and 6 volt, same polarity. Now this divided by 1 by R1 is 1 by 1 plus 1 by 2 plus again 1 by 1. So this is going to be 3 minus 2 plus 6 divided by 1 plus 0.5 plus 1. Okay, so what will happen, this is 9 minus 2, this is going to be 7, this is 2.5. This is the effective voltage or effective EMF of this combination. Clear? We will be getting this as 2.8 volt. If we simplify, we will be getting this as 2.8 volt. Now what is the next question? R effective. R effective is this one. Okay, R effective, 1 by R effective is 1 by 1 plus 1 by 2 plus 1 by 1 again. So R effective is 1 by R effective is how much? This is 2.5. So R effective is 1 by 2.5. So 1 by 0.25 will be 4. This is going to be 0.4 ohm. 0.4 ohm. Right. Now they are asking what is the current in the external load? 1.6 ohm. Terminal voltage is what they are asking. Terminal voltage. Right. So 2.8 volt is the effective EMF and internal resistance, effective internal resistance is 0.4 ohm we got. So if we draw equivalent circuit, so all these three putting together we are putting 2.8 volt and small r, this is actually E effective, and R effective we got as 0.4 and this is going to be 1.6 ohm. What they are asking is current in the external load. Current in the external load. So once if we make the circuit into this form, then it is easy to find. So I is equal to E effective divided by R equivalent plus R. I is equal to V by R equivalent, right? So using this. So E effective is how much? 2.8. This is going to be 0.4 and this is 1.6. So 2.8 divided by 2 we will be getting 1.4 ampere. So that is the current that is passing through the circuit. Take a question. We just need to find the value of current. Now what is the value of current through 6 ohm? So we can do this using nodal analysis also. If we find the node voltage at terminal A, then that voltage divided by the 6 ohm we will be getting the current. So that method also you can try, just practice that method, nodal analysis also for this question. Since we are studying about parallel combination, I am going to use that concept to solve this question. So this cell and internal resistance, this cell and internal resistance, so this one and this one, they are connected parallelly with one external circuit. So if we are able to find equivalent resistance, okay, then equivalent EMF, then if this is external resistance, then we will be able to find the value of current. I is equal to E equivalent divided by R equivalent plus R. Okay, so let's find the equivalent EMF. So this is parallel combination, so E1 by R1 plus E2 by R2 divided by 1 by R1 plus 1 by R2. Now what is E1? 6 divided by 12. Here the polarity is changed, so I am going to put minus 4 divided by 4 divided by 1 by R1 is 12 plus 1 by R2 is 4. So if we solve this, we will be getting numerator, we can take the LCM as 12. This will be 6. Here this is going to be 3 minus 12 divided by. Here again numerator, this is going to be 12 and this is going to be 1 plus 3. So 12 will be cancelled off. We will be getting minus 6 by 4. So 3 by 2 is the EMF. So I am putting here 3 by 2. R equivalent, if we try to find R equivalent, this is nothing but R1 R2 divided by R1 plus R2. So 12 into 4 divided by 12 plus 4 will be getting 48 divided by 16, which is nothing but 3 ohm. Okay, so this is going to be 3 ohm. This is already given in the question, 6 ohm. So I is equal to how much? 3 by 2 divided by R equivalent is 3 plus how much? 6. Okay, so 3 divided by, this is going to be 9. So 2 into how much? This is 3 by 2. Okay, so 3 by 2 divided by 9. 3 by 2 divided by 9. This is going to be 3 by 18. 3 by 18. Okay, so we can have 1 by 6 ampere. So C is the correct answer. Clear? So if there are n identical cells, first cell, second cell, then so many cells, this is nth cell. Internal resistance R is also connected like this. One external resistance capital R is also connected. So here I is equal to E equivalent divided by R equivalent plus capital R. And what is E equivalent? E equivalent is E itself. E equivalent is E itself. We have already seen E equivalent is what? E1 E divided by R plus E divided by R. Likewise NE divided by R. And this is nothing but 1 by R plus 1 by R plus 1 by R. So what will happen if we take 1 by R outside? This is going to be NE divided by, if we take 1 by R outside, this is going to be N. Correct, no? 1 plus 1 plus 1. So if we cancel all this, we will be getting E itself. So E equivalent is E. Parallel combination, so R equivalent is nothing but R by N. R by N. So if we try to find the current value, this is going to be E divided by R equivalent is R by N. Equal number of equal resistances N times, if we connect, that is nothing but R by N. 2 resistances R by 2, 3 resistances R by 3. So R by N plus capital R. So I will become E divided by R plus NR, and this N will go here. So this is the current that we get from equal cells with equal internal resistances if we connect in parallel. Okay, so I is nothing but NE divided by R plus, the small r is nothing but Small r is nothing but internal resistance and capital R is external resistances. What about series? What we got? If this is parallel, this is for parallel, then for series what we got? NE divided by NR plus R. This is what we got in series, the value of current. Compare and study. So okay students, so today we have continued with the parallel grouping of cell. We did some problems also. So see students, this is mixed grouping of cell. We have seen series grouping of cells and we have seen parallel grouping of cell. In mixed grouping you can see both. Look at this. So here R, E, then dot dot dot, that is so many cells and internal resistances. Similar cells we are connecting in series. Finally we have nth one. Okay, nth one, nth internal resistance and nth cell. So this cell, this is associated with the nth cell. Likewise we have a series connection, then again another series connection like that. So this is again R, E up to how many? Again n times. Likewise here also we will be putting dots. Okay, so many number of series rows like that. Okay, likewise then after that we will be getting mth row. This is nth cell, n cells in a row, and there are totally m rows, n, e, r, e, then again r, e. Likewise how many times? This is nth time. External resistance is also connected. So just think, what will be the equivalent EMF? What will be the equivalent EMF in a row, in a single row, what will be the equivalent EMF? E equivalent in series was what? NE. E equivalent in series is NE. E equivalent in parallel, what was that? Just E. Remember, in parallel connection E equivalent is just E, and in series connection E equivalent is NE. So what we can put here? Series, how many are there? NE are there. So for all of them the equivalent EMF is NE, 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 NE like that. So for every line the equivalent EMF is NE. So these are all parallel, right? So for one, if it is E, then for all in parallel it was just E. Now here for one row it is NE, so for all of them putting together we will be getting NE. So this is E equivalent. What about R equivalent? In a single row, R series is how much actually? NR. So R parallel will be R by N. So what is the overall R equivalent here? In one row there are, the total resistance is NR. That much M number of parallel lines are there, so we will divide with the M. Clear? Is it clear? Just applying in series and resistance thing. So what will be the value of current? Value of current is always E equivalent divided by R equivalent plus the external resistance. So I is equal to, what is E equivalent? NE. Then what is R equivalent? NR divided by M. Okay, N number of cells in a row and M rows divided plus R. So what will happen? This M will come here and M will stay as LCM, that will go to the numerator. So MNE divided by NR plus MR. So this is the value of current in mixed grouping of cells. Next topic is condition for maximum current. In order to get maximum current, what is the condition? This most of the questions from mixed grouping are based on this condition. So first we will write the equation for current. This is nothing but MNE divided by, so what is this M? M is nothing but number of rows, N is nothing but number of cells in a row. Okay, so MR plus NR. So for this current to be maximum, actually this MR plus NR must be minimum. Okay, so how this result, okay, what is the condition for maximum current, we will have to derive mathematically. So see, MR plus NR is equal to root of MR minus NR whole square plus 2 root MR NR. Can we write like this? If you have doubt, we should expand this and see. So this is nothing but this is like A minus B all square. So I can write MR plus NR minus 2 root MR NR plus 2 into root MR NR. Now this and this will be cancelled off, both are same. So we can write this term in this way also. Correct? Now, so this is the expression which we are concentrating. Okay. Now, how to make this expression minimum? This expression can be made minimum if we get this is equal to this. That is, MR is equal to NR. Okay, then what will happen? This entire term will become 0, no? MR minus NR, okay, whole square. This will become 0. Okay, so that we will have only 2 root MR NR. So we will, the condition for getting maximum current is nothing but the number of rows into external resistance is equal to number of series cells into its internal resistance. So this is the condition for maximum current. Now suppose if we write MR is equal to NR. So if we write R is equal to NR divided by M, this is nothing but R is equal to internal resistance equivalent. So if external resistance is equal to internal resistance equivalent, we will be getting maximum current. Note it down. So I is equal to what? I is equal to MNE. I is equal to MNE divided by MR plus NR. So when these both are same, what will happen? I is equal to MNE, MR is equal to NR. Okay, then what we will be getting? We will be getting 2MR. Correct? 2MR. This M will be cancelled off. We can write I is equal to NE divided by 2R. So this also, this way also we can write this expression. So take this question, students. 36 cells, each of internal resistance 0.5 ohm, EMF is 1.5 volt. Each are used to send current through the external circuit of 2 ohm. Find the best mode of grouping for maximum current. So 36 cells they have given, so that is nothing but the number of row into number of columns, number of rows into number of columns. M into N is what? 36. So one condition is ready. Another condition is maximum current. So maximum current, the condition is MR is equal to NR, number of rows into external resistance is equal to the number of cells in each row into its internal resistance. Correct? So let's take NR by M. NR by M is equal to capital R. N we do not know, M we do not know, but we know internal resistance. So N into 0.5 divided by M is equal to this capital R is given as 2. So let this be the second equation. So 1 by 2 or 1 into 2, whatever way we want we can do. So Mn divided by N into 0.5 divided by M is equal to what? 36 divided by 2. So N if we cancel, this will become M square, and we will be getting, this is going to be again 18 into 0.5. So 0.5 is nothing but 1 by 2, this will become 9. M we will be getting as 3. So 3 rows. Then we need not even try to find the rest of the things, we can directly mark because M is nothing but number of rows we got directly. Now anyway, let's find this. So M into N is equal to 36. So N is equal to 36 divided by 3 will be getting 12 cells. So that is what given in this answer also. So sometimes this taking two conditions from the question, and when we try to solve it, it may take some time. So if you remember a shortcut, easily we will be able to find the number of rows and number of columns. So I will give you that shortcut, please note it down. Okay, see, number of cells in each row, number of cells in each row, if you need to find, you can do capital NR by R. This capital N is nothing but the total number of cells. Capital N is nothing but the total number of cells. Same way, number of rows, if we need to find, again same way, capital N into small r divided by R. Okay, so number of cells in each row, number of rows, total number of rows we can find using this equation. This small n is nothing but the number of cells in each row. This is nothing but number of cells. This capital N is nothing but total number of cells. External resistance, internal resistance. Okay, use this. Verify whether you are getting the answer for this question also. So okay students, so cells, how to find terminal voltage, what is EMF, grouping of cells like a series grouping of cell, parallel grouping of cell, mixed grouping of cell, how we will be getting maximum current for each case, all these things we have studied, we have done some number of problems also. So practice well, make the topic thorough. Thank you students, goodbye, good luck.